Hello, everyone, and welcome to today's webinar, The Impact of MBT Sepsityper, the Lahey Experience. I am Jennifer Woods of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Bruker Daltonics. To learn more, visit bruker.com. Let's get started. Before we begin, I would like to remind everyone that this event is interactive. We encourage you to participate by submitting as many questions as you want at any time you want during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. If you have trouble seeing or hearing the presentation, click on the Support tab found at the top right of the presentation window, or report your problem by clicking on the Ask a Question box located on the far left of your screen. This presentation is educational and thus offers continuing education credits. Please click on the Continuing Education Credits tab located at the top right of the presentation window and follow the process to obtain your credits. I now present today's speaker, Felicia Maida, MT, Senior Technologist, Microbiology Laboratory, Lahey Hospital and Medical Center. For a complete biography on our speaker, please visit the Biography tab at the top of your screen. Felicia, you may now begin your presentation.
Thank you for having me. So again, my name is Felicia Maida, and I am a Senior Tech 2 at Lahey Hospital and Medical Center in Burlington, Mass. I have been working in the microbiology department for about 30 years, and after this past year, it actually seems like more of a lifetime, so can't wait for this COVID to go away. Okay, a little bit about our hospital. So as I said, we are out of Burlington, Massachusetts. We are located about 20 minutes northwest of Boston. So Lahey serves about 3,000 outpatients a year and has 335 inpatient beds. We also have an acute ambulatory care center. Our emergency department is a level 2 trauma center that operates 24 hours a day, 7 days a week. And we have the staff that we have on hand teach at Tufts University School of Medicine. We are a teaching hospital at Tufts University School of Medicine, and our physicians actually hold teaching assignments at Harvard Medical School and Boston University School of Medicine. So that's a little background about our hospital, and now I will move on to life before MALDI. So life before MALDI. We did use biochemicals, some of them here, bioescalin, salt, tube coag, to name a few. We also use instrumentation as well. I'd like to now review the workflow in our department for when a positive blood flags. Excuse me. So the positive blood will alert on our instrument. We would pull the positive blood. We will make our gram stain. We aliquot 3 mLs of blood into a sterile plastic tube. And then we would wait for our gram stain to dry, read the gram stain, and depending on what the organism is, no matter what the organism is, we would phone it to the appropriate floor provider. Depending on what the organism is that we see in the gram stain, we would then set up the biochemicals and sub it to the appropriate media as needed. So to give you some examples on how we would work this up, if we had gram-positive coccyne clusters, we would plate this to a sheep blood agar, and we would add a furazolidone disc, which is also known as FX disc. And we use the FX disc to rule out micrococcus at 24 hours. We also would place 3 drops of the blood into a tube coag, and we would then wait examine that at 2 hours, 4 hours, and 24 hours to see if there is any coagulation to rule out Staph aureus. If we had gram-positive cocci in pairs and chains, we would plate it to a sheep blood. We would add an optogen disc, which is the P disc. So at 24 hours, we can look, and that will help us rule out strep pneumo. We would also add a chocolate agar. And we then would also take 3 drops of blood and put it into the bioesculin tube and the salt tube, which I showed you on the previous slide. Those tubes we use to rule out Enterococcus at 24 hours. So you can see we're plating it, we're using biochemicals, and it's taking us about 24 hours to get any type of identification. For gram-negative rods, excuse me, we would plate this to a sheep, a chocolate, a McConkey, and a CNA. Now, the reason behind the CNA is we use this just to make sure we do not miss any gram-positive bacteria that could have been growing in the blood that we did not see on the gram stain. For gram-positive rods, we would plate this to a sheep in a bioesculin tube. And again, the bioesculin tube is to help us rule out Listeria at 24 hours again. So as I was saying, at 24 hours, we can determine a lot of what's happening with the organism that we saw in the gram stain. We observe the growth on the plates. We will then identify the organism, if possible, with the biochemicals that were set up. We would look at the morphology on the plates, and hopefully between the biochemicals and the morphology, we are able to have some type of an identification of the organism. If there is no identification at this point, then we would move on to other biochemicals if we needed to, or use our instrumentation at that point. So if we didn't have that ID at 24 hours and we needed to put it on instrumentation, or we set up other biochemicals, now we're talking another 24 hours before we get that identification. So here we are 48 hours later, and we finally, hopefully, will have an identification. So just to kind of review, start to finish using biochemicals before MALDI was implemented, it's going to take us 24 to 48 hours before we're able to identify that organism. So in June of 2015, we implemented our MALDI Biotyper. We performed a validation on approximately 100 different isolates over a period of a few months, and multiple technologists were involved when we did this. We did have 100% accuracy from this validation. I'm just going to talk about the Sepsityper and the rapid Sepsityper validation since we're on the slide. For the Sepsityper validation, we used around 80 organisms, mix of gram-negatives and gram-positives, and we had about 91% identify using the Sepsityper. And when the rapid Sepsityper was implemented, we just did a very limited validation, and that identified about 90% of our positive blood cultures during that validation. So just to give you an idea of what happens in our microbiology department, we have multiple technologists that run targets daily, and we use that to identify our organisms. So it's great because instead of waiting 24 hours for identification, using the MALDI Biotyper, we're now getting identification out the same day. Each bench is responsible for their own target. So our setup is we have 4 different benches. Everybody has their own target, so everybody can work at their own pace and do their own work. We do give priority to the blood bench. So if people have to run targets, people are very good about giving each other the time to get on, and especially, like I said, if the blood bench needs to get on there, they are the first to get on there. So implementation of our Sepsityper came in October of 2017. So I will review the workflow that we use for the Sepsityper as to when this was introduced. The positive blood alerts, we pull the positive blood, we make our gram stain, we aliquot the 3 mLs of blood into the sterile plastic tube. We then read our gram stain. Again, we will report it, and we will put it to the appropriate plates. From here, we save those aliquots of any other positive bloods that have gone positive up until 10:30. At 10:30, we then take any aliquots that we have that need an identification, and we will then put that on the Sepsityper and have identifications, hopefully, on those different patients for our rounds at 11:30. We do infectious disease rounds daily at our hospital, and we like to give as much information on patients that we can at that time. Once ID rounds are over, any other positive bloods that flag, we then, again, batch, and we'll leave our tubes under the hood, and we'll do another run at 2 p.m. in the afternoon. So this workflow, we were batching. The bloods would come off. We would batch. So twice a day, we were getting out identification for positive bloods. So how is the Sepsityper performed? The way that we have this is just a way that we set up our algorithm, and I'm sure facility is different. So for us, you would set up Sepsityper if the first bottle or set is positive with gram-negative rods, gram-positive cocci, or large gram-positive rods. If your second set turns positive from the same day, we don't have the technologist set up the Sepsityper again. We are assuming that if it's gram-negative rods and we get an E. coli in the first set, that the gram-negative rods in the second set from the same day is also going to be the E. coli. In our laboratory, we do it a little differently for coag-negative staph. So if you do have a coag-negative staph or gram-positive cocci on the second set from the first day, the same day, we would also run the Sepsityper. If we have a new bottle from a different day and it had gram-negative rods, we would set it up. We want to make sure that the second day or a different day is the same as what was previous. If it was gram-positive rods, we don't set it up. We see a lot of contamination, so we don't take the time. We just wait for that to grow. And if it was gram-positive cocci, again, we're not going to set it up. But if it is greater than 3 days or it's coag-negative staph, we would set it up. And again, just the algorithm that we use here at Lahey Hospital Medical Center. So what is the procedure for Sepsityper? I'm going to just talk you through this. You take 1 ml of blood. You place that in a sterile tube. You're going to add 200 microliters of the lysis reagent. You're going to vortex that and then spin it. You're then going to discard the supernatant, and you should have a pellet that's visible. If you don't have a pellet that's visible at this point, that's okay, but we like to see a pellet knowing that we do have some kind of organism in there, but we still will continue with it even if we don't have a pellet. We then add 1 ml of wash, and we spin that for 1 minute, and then we discard the supernatant. You have to be very careful when you're discarding the supernatant, though, because that pellet, as you're discarding the blood and the supernatant that's in there, sometimes the pellet can be sticky and it can come up, and if that pellet gets moved at all, then you really want to go back and respin it, because you don't want to lose any of that pellet because that has the organism in it. So the next part is the extraction. So the extraction, on top of what we just did, We're then going to add 300 microliters of the HPLC water. We resuspend that, and then we add 900 microliters of ethanol. We'll mix that suspension, and then we spin that for 2 minutes. Again, we're going to discard the supernatant, careful not to touch the pellet. We do use these very fine tip pipettes that work great for this. We are going to then air dry that pellet for 5 minutes. We want to try to get off as much of that ethanol residue as we possibly can. Then we need to make a 1-to-1 with the formic acid and the acetonitrile and resuspend. So depending on the size of the pellet, you can kind of play with the amount of formic acid and acetonitrile that you need. We average about 25 microliters depending on the size of the pellet. So it could be 25 microliters of formic acid along with the 25 microliters of the acetonitrile. And then we resuspend that. We spin that for 2 minutes. Again, discard the supernatant. We don't discard the supernatant at this point. The supernatant is what we use on the target, and then that gets read by the MALDI at that point. So all in all, total turnaround time, approximately 25 to 30 minutes with the hands-on time, maybe 15 minutes. It's tedious because there's a lot of spinning and discarding and spinning, but identification, like I said, in about 25 to 30 minutes. So how does this affect patient antibiotic therapy? I have a few cases that I'm going to go over that we had here in our hospital. So the first case study, we had a positive blood flag. We did a gram stain on it, and as you can see here, we had small gram-negative rods. We plated it to our plates that we would, our blood, our chocolate, our CNA, and our McConkey. We phoned it to the floor to let them know that the patient had gram-negative rods. We then performed our Sepsityper, and the result was a Bacteroides fragilis. Needless to say, we were a little surprised to see this. We had already alerted the care team that they had a gram-negative rod earlier after reading the gram stain, and now this changes the whole aspect of patient therapy because we're dealing with an anaerobe versus some type of gram-negative rod. So this was a great situation for us where we called the care team, we let them know there was a gram-negative rod, and then half an hour or however long later, I don't know what time this was called, all of a sudden we have an identification of B-frag, which is an anaerobe, which requires different antibiotic therapy. So this was great for us. It's a great feeling to know that you can change the patient care within 24 hours. I mean, this is being done so fast, and we can let the care team know so they can treat appropriately. So our next case study, same thing, the blood culture flagged positive. We did a gram stain. This one came up as gram-positive cocci in clusters. So again, we plated this to our blood plate. We added the FX disc, and we called it to the care team, letting them know that it was gram-positive cocci in clusters, suggesting staph species. We ran our Sepsityper, and voila, Aerococcus urinae, which is not a Staphylococcus species. So again, you can see the impact of patient care and therapy due to the MALDI and the Sepsityper and what it just does to the laboratory for us. So Aerococcus urinae, as we know, is part of the Streptococcus family. So it was great, again, for us to call and let the care team know that it was a streptococcus, Aerococcus urinae, and they were then able to change the patient therapy and treat appropriately. So again, for us, it's amazing because you're going from 24 hours to 48 hours for an identification, and especially something like Aerococcus, which would take 48 to 72 hours. It's just such a great instrument. So our implementation of the rapid Sepsityper came in April of 2019, sorry. So the workflow for the rapid Sepsityper is very similar to what it was for the Sepsityper, just a few differences on this. So the positive blood will alert. We pull the blood. We make our gram stain, put it to our plates. We aliquot our 3 mLs. We read our gram stain. We phone it to the floor, the physician, the care team. And then instead of waiting and leaving our tube for other positives to that 10:30 a.m. mark, we now will perform our rapid Sepsitypers as we go. So with the rapid Sepsityper, there is no batching as we batched prior to this for just Sepsityper. And due to that, we're able to, again, get the results out to our infectious disease department for that 11:30 a.m. rounding. So the workflow for the rapid Sepsityper is pretty much the same as the Sepsityper. It's just we don't have that extraction process. So I'll go through the rapid Sepsityper workflow with you. So again, you would take your 1 ml of blood, you put in your microcentrifuge, you add your 200 microliters of lysis, you're going to vortex that for 10 seconds, you're going to spin it for 2 minutes, you're going to decant your supernatant, again, carefully avoiding that pellet. We're going to then add 1 ml of the wash. We'll resuspend by pipetting up and down. We will spin that for 1 minute. We will then remove the supernatant, again using that fine tip pipette. And this time, the supernatant is discarded because for the rapid Sepsityper, we're actually using the pellet. So this is one of the main differences between the Sepsityper and the rapid Sepsityper. The rapid Sepsityper, we stop at this point where we have the pellet, and we're going to use that pellet on our target for the identification, versus the Sepsityper, at this point we would continue with the extraction process, and then we would be using the supernatant to put on our target for identification. So for my third case study, this was using the rapid Sepsityper. We had a blood flag positive. The gram stain was performed, and it showed gram-positive rods. So this we would plate to our blood plate, and where it was small gram-positive rods, we probably would set up a bioescaline with this. When we performed the Sepsityper, the result for this one was an Actinotignum shalei, which is formerly known as Actinobaculum shalei. So due to this being an unusual organism in the bloodstream, this is not something that we tend to see very much of. We did a little bit more of an investigation to see if we could figure out where this may have come from. So when we looked at the patient's chart, we did see that the patient also had a urine culture that was positive for greater than 100,000 colony-forming units per ml of these pinpoint colonies. Due to that light growth of the organism, the technologist was not able to identify the organism using the MALDI. When we let them know what was growing in the blood culture, we were able to pull the plates out and look at the colony morphology, do a gram stain on it, and we also performed a PYR, which was positive. And for our actinobaculum, we should have a positive PYR. This enabled us to sign the urine culture out as presumptive actinotignum at this point. And then on day 2, so at 48 hours, the colonies were bigger and they were able to run the MALDI-TOF and confirm this identification. So this another great situation where we were able to help the urine bench identify the organism there because it was in the blood culture, and if it wasn't for the rapid Sepsityper identifying it, the urine culture would have waited another 24 hours for that identification to go out. So just to review the timeline comparisons for all 3 methods, the first one is obviously biochemicals and instrumentation. So hands-on is quicker. It's about 10 minutes. You're making your gram stain, you're plating it, but you're waiting 24 to 48 hours to get that ID that you can report out. For the MALDI Sepsityper, it's about 15 minutes hands-on, and we're looking at about 25 to 30 minutes to get the identification after it runs on the MALDI. And then for the rapid Sepsityper, it's quick. It's about 5 minutes hands-on tech time and, 15 to 20 minutes total turnaround time for the identification as well. So I did ask one of our infectious disease doctors, as I have him here as Dr. M, if he would just give me a comment or thoughts on our new system when we brought the rapid Sepsityper into play. And Dr. M's comment to me was, patients are put on therapy a day earlier due to the rapid MBT Sepsityper. So Dr. M also had a Shazam moment, as I would call it, and I'll explain his Shazam moment in the next slide. So we had a positive blood culture that flagged. It had gram-positive cocci in pairs and chains. So we did phone this to the floor or the care team to let them know that it was gram-positive cocci in pairs and chains, and we probably suggested streptococcus or enterococcus at this point. We performed our rapid Sepsityper, and we ended up identifying this organism as a beta hemolytic strep group A. So as you know, this is a very serious organism in the bloodstream. And we did look into the patient's chart to see what else was going on with this patient. While investigating, we found the patient had 2 wound cultures. And when the technologists read them at 24 hours, they were super pinpoint, and they just didn't feel they were going to be able to get any type of an identification from them. So they reincubated the plates. Well, due to the identification in the blood culture, we did perform a latex on these tiny colonies, and we were able to see agglutination in group A, and we were able to sign both of these wound cultures out as group A strep. So it was nice to be able to put everything together to let Dr. M know that it was in the blood culture, it was in the wound culture, and it was, again, great antibiotic therapy for him, and he knew exactly what was going on with the patient. I have a little bit of data here that I was just going to review with you that we took from October 2018 to September of 2019. And it was the total Sepsitypers tested, so we did about 708. The total identified were about 73%. Oh, sorry. So here's the chart. I know it's very hard to see. So I'm just going to go over a couple of the numbers. In February of 2019, we only had 48% identified. That was the least identified over the whole year of looking at this data. And the highest number that we had was in December of 2018 with 95% identification. And throughout the chart, again, I apologize for how small it is, but you can see the numbers vary. So again, 48 was the lowest, 95 was the highest, but we had a lot of 70s in there. There were some 80s, some in the 60s. And so this could just be due to organism. If we didn't have a pellet, I did talk about we would still continue to use it if we had a pellet. And this is with Sepsityper and Rapid Sepsityper. So just a little bit of data to show you. And I believe Sepsityper does state that it will identify organisms 70% of the time, which, like I said, if I go back here, you can see of the 708 that we tested, we did have a total identification of 73%. So we are falling within those limits. So in conclusion, I would like to just say that the Rapid Sepsityper workflow is an extreme asset in our laboratory. The results, as I've demonstrated, are determined within minutes of the blood culture flagging positive. There's no more waiting 24 to 48 hours. It provides accurate identification, as I went over when we have never had a miss. We have never had anything misidentified. It provides results to our clinicians in a more timely manner. Like I said, they're getting these results by 11:30, and then anytime it comes off, we're just running it as we go, and the results are going in. So, they're getting results the same day. And the rapid detection is also decreasing the hospital length of stay by about 2.5 days in our hospital. This also gives us the ability to decrease the amount of biochemicals that we order and that we use in the laboratory, and it is a useful tool for our antimicrobial stewardship. I'd also like to say that our technologists love this instrument. It's very easy to run. It's very user-friendly. Again, it's just a great asset to our laboratory. And with that, I would like to say thank you, and I will open it up to questions.
Thank you, Felicia, for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you would like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many questions as we have time for. Let's get started. Our first question is, how long did it take you to validate the Rapid Sepsityper?
Hi. So as far as the validation for the Rapid Sepsityper, like I said in the presentation, we did do a limited validation due to we had such a larger validation when we did the actual Sepsityper. So this was just very quick. We knew that the Sepsityper worked. This was just a matter of, instead of doing the extraction process, you stopped before then. So we had already gone through all of that with the regular Sepsityper, so this was very quick and easy to do.
Thank you, Felicia. We have another question here. Have you ever reported an organism from the Rapid Sepsityper that did not grow on the plates the next day, or was a different organism?
I can honestly say that we have not. What we have found is organisms sometimes that we weren't sure even existed. We are finding more organisms, or identifying, I should say, more organisms using the Rapid Sepsityper than if we were using typical biochemicals. So I can honestly say that everything that we have run on the Sepsityper, we have had match on the plates the next day and confirmation due to morphology.
Thank you, Felicia. Our next question is, what were the reasons that your lab was able to move from batched Sepsityper prep to on-demand prep with the Rapid Sepsityper protocol?
So what happened is the regular Sepsityper, like I stated, because it had that extraction process, we just felt that because it took a little longer, we would batch them and then we would go into that extraction process and work with as many positive blood cultures that we had. Due to the rapid Sepsityper and not using that extraction process, that enabled us to be able to work as each blood culture flagged positive, so we could just run it as we go instead of waiting until that 10:30 mark.
Great, thank you. We have another question. How could this be used with the MicroScan?
That is actually the instrumentation that we have at Lahey Hospital Medical Center, and it works great. It's Lab Pro, so it's a great system. We have everything hooked up as far as MALDI goes. Rapid Sepsityper is a little different because it is the research side. So the research side is done, you are actually manually entering versus when you're using the MALDI with the MicroScan. That's an all-automated system through Lab Pro. So the Rapid Sepsityper, again, is used on the research side. So that's manual. So everything is entered manually into the MALDI typer, and then we enter it manually into our system. For the MALDI and the MicroScan, that is all automated, so all of that information from our benches go into the MALDI, goes into the MicroScan, and then the MicroScan then is putting that information into our system.
Thank you, Felicia. Our next question from the audience is, do you proceed to full extraction if no identification?
We have done that in the past, so yes, depending on what we see, if we're unsure of what it is and we really want to get the identification out, we will continue with the extraction process, and we have done that.
And what is the acceptable score to call it a good identification?
So for a Sepsityper, because you're working on the research side, they do lower the score a little bit. So as long as you receive a 1.8 or higher, then you are able to use that as a preliminary ID into our system.
Great, thank you. And our next question here is, how do you report out your identification, seeing that it is identified from research use only?
So we have come up with a comment that states the identification, it's a preliminary identification from a liquid culture, and we would have confirmation the next day. So let's just say, for instance, we had an identification of an E. coli. Then the next day, we would look at the plates, look at the morphology, and then we would run the actual organism on the MALDI typer on the clinical side for confirmation of that E. coli. We would then take out our preliminary results and leave that as an E. coli.
Thank you, Felicia. And our next question is, how many samples can you treat at the same time with the Rapid Sepsityper?
So as far as many samples, because we do it as we go, or sometimes we will have multiple blood cultures that flag. We come in at 7 a.m., so if we have 4 or 5 blood cultures that go positive right at 7 a.m. between 7 and 7:30, we will, so to speak, batch our Rapid Sepsityper at that point. So we could potentially be doing 5 at a time, but we wouldn't wait till that 10:30 mark. And because the target has 48 spots on it, we usually run them in multiples just to make sure, because we've done the process, that extraction, well, not an extraction, but we've done the lysis process. So we will spot it twice, because if the first one doesn't work, we want to hopefully get it to work on that second spot. So we have, like I said, 48 slots. So depending, we can run, if we have 5 positive blood cultures, that only takes up 10 spots on the target, and we can run those 10 spots at the same time, and within 10 minutes we'll have an identification for 5 different samples.
And how do you identify the 27% of organisms that the Rapid Sepsityper cannot ID?
We do have other instrumentation in the laboratory, or we will wait, set up biochemicals if need be, or we'll just wait till the next day for the organism to grow, and then we would just run it on the MALDI Biotyper.
And in your study, what is the percentage of agreement in comparison to reference technique culture? Any numbers about discrepancies, errors, etc.?
I don't have that information with me right now. I could look into that and get back to you.
Perfect. Thank you. Felicia, our next question here is, did Rapid Sepsityper allow you to move away from expensive PCR testing? If so, how was the process of changing?
We did not have PCR testing when the MALDI was introduced, so that was really never, that didn't really affect us.
Okay, great. And are you able to make identifications when a blood culture contains multiple organisms?
If the blood culture does have multiple organisms, we would not put it on the Sepsityper. We would just wait for that 24 hours to see what's growing on the plates, and therefore, if it is polymicrobic, we would just put it on the MALDI to get both identifications.
Okay, thank you, Felicia. Our next question. With lower score, less than 1.8, do you report to genus level only?
We do not. If it does go below 1.8, if we were to call it, for example, gram-positive cocci in clusters suggesting staph, let's say we had an identification of a staph epidermidis at 1.79, which is below that 1.8, we still would not report that as a coag-negative staph. We would just leave the gram stain in, stating it's gram-positive cocci in pairs and clusters suggesting staph. What we would do is, as I stated, we do have infectious disease rounds at 11:30. We would let the ID physician know it looks like it's going to be a coag-negative staph. We didn't get it high enough on the Sepsityper, and, we'll let you know more tomorrow. So we do give the ID staff information, but it's not anything that we put into the patient's chart or into the system or that we would call.
Thank you, Felicia. Our next question here is, will it ID Mycobacteria species 2 like MAC or MAC?
We do use the MALDI-typer for our microbacteriology lab, yes.
Okay. Great. And what do you do if there's more than one organism seen in the original blood gram stain?
So this, if we saw gram-negative rods and gram-positive cocci in pairs and clusters, we would just report both of those to the floor. We would put that in the patient's chart, and again, we wouldn't go any further due to it being multiple organisms. We would just wait for the 24 hours for them to grow and then perform identification on MALDI the next day.
And can you use rapid protocol pellet for AST?
We do not. We actually have to use an organism in our laboratory.
Okay, thank you.
The colony.
Okay, thank you. And our next question is, how about the cost of identification using Rapid Sepsityper?
I don't have that information in front of me, so that's something that I could get back to you with.
Okay, perfect. And our next question here is, were you able to identify any fungi?
We are in the process of getting ready to do a validation for our mycology laboratory.
Great. Thank you so much, Felicia. And this question may have been answered already, but I'm going to ask it anyway. How about multiple organisms in the blood?
So yes, that was a question I have answered. And again, depending on what is in there, we would report it, put it in the patient's chart, but we would not perform a Sepsityper.
Okay, thank you. And for other benches, do you use a suspension of an isolate grown from a colony?
No suspension is necessary. So if the organism is growing and we have a colony, we just use that colony, put it right on the target, and it's run on the MALDI.
And is the Rapid Sepsityper run on all shifts?
It is run on first and second shift. Third shift, we we only have one person that comes down to the microbiology laboratory on our third shift, and they just pull the bloods and they call them, and the rest is left for our first shift.
Okay, let's see. We've got some more questions. What percentage of the questionable ID agreed with the final ID?
Again, if we had anything that was below 1.8, we don't use that for identification, so we would just wait for the organism to grow the next day.
Okay, thank you, Felicia. Our next question is, let's see, what was the percentage of identification for the Sepsityper method, the longer method? As you said, your rapid Sepsityper identification is 70%. 70%.
So as far as the Sepsityper method, I don't have the exact numbers, but I believe it is higher just due to that extraction process, because once you use that extraction and you're adding your ethanol and you're really pulling out those proteins, you do get a higher number. So like I had said previously, if we do a rapid Sepsityper and we don't get an identification, we could move on to the extraction process, and we usually would get it. I don't have the exact percentages in front of me, but it's definitely a higher percentage using the extraction versus not.
Okay, thank you, Felicia. We have a few more questions. What are the Sepsityper results in cases where you have mixed infections or polymicrobial samples? Does the Sepsityper pick up both? If you do more than one spot, how many spots do you spot when you perform rapid Sepsityper?
Okay, so we actually have had situations where we did see gram-positive cocci, say, in a gram stain. And when we did the rapid Sepsityper, all of a sudden we did have a gram-negative identification. Now, my understanding of the Sepsityper is even if it is polymicrobic, it will identify the higher weight of the organism's protein that's in there. So even if you do have multiple organisms that you don't realize you have multiple organisms, if you run that, you would still get an identification. We're hesitant to report that, or we will go back and we will resub the bottle. We will look. So example, if we had gram-positive cocci and then we had an E. coli that identified on the Sepsityper, we would go back, we would look at the gram stain, we would see if there were any gram-negative rods in there. If there weren't, then we would wait till the next day. We haven't had any situations where that has happened, that it's been due to cross-contamination or anything. It actually has grown out the next day, but we will wait that 24 hours just to make sure. We don't obviously want to report an incorrect result on a blood culture. As far as how many spots, again, like I said, we usually will run 2 spots. So we use the pellet that we have, and we will take that. Sometimes it can be sticky. And again, with the MALDI, heavier, lighter is better. It's microorganisms that they're looking for. So it's the more protein you have in there, it doesn't always read it properly. So just 2 spots is what we use. We overlay that with formic acid. We put our matrix on. We put it on the instrument and hopefully get an identification.
Great. Thank you, Felicia. We have time for just a few more questions, and I want to remind the audience that any questions we don't have time for today will be answered by the speaker via the contact information that you used to register for this webinar. So here's our next question. Do you use rapid protocol for mycobacteria blood culture?
That is done in our microbacteriology laboratory. I do not work back there, so I could find out that information for you and get you that answer.
Okay, perfect. And our next question is, if the ID is E. coli, how will you report this, knowing there's a possibility that this is could be a Shigella species?
For us, we have never identified an E. coli from the MALDI TOF that the next day has been a Shigella. So Shigella is really not something that we worry about at our facility. If it comes out E. coli, we report it as an E. coli, and like I said, we've been doing this since 2015, so over the past 5 years, we have never had an E. coli that actually grew out as a Shigella the next day. We've never had any discrepancies at all with our E. coli.
Okay, thank you, Felicia. Our next question here is, does the stewardship team change therapy based on ID along from Sepsityper versus having an AST result or a result from a resistance gene, especially in the case of gram-negative rods?
So for our stewardship team, like I said, this is a great tool for them, and they will change their therapy based on that identification from Sepsityper. As far as resistance genes, Sepsityper, MALDI-typer doesn't do AST results, so therefore we can only give them identification, and again, they will change therapy as needed.
Great. Thank you so much, Felicia. We have one last question here. Sometimes you cannot see a polymicrobial on the gram stain. Have you had discrepant results in the case where one of these samples got put on the MALDI and there were 2 organisms present in the PBC?
Again, we really have not had any discrepancies at all using our MALDI, our Sepsityper, or our rapid Sepsityper. Like I said, it's a great instrument for us. We love it. We just absolutely love it, and we really have not seen any discrepancies. Everything that we've reported has confirmed the next day by culture.
Thank you, Felicia. Do you have any final comments for our audience before we go?
Just that, like I said, it's a great asset for our laboratory. Again, our technologists, love this instrument. It makes life easier for us. It's great for patient care. Our ID doctors love it. We are very thankful that it was made, I guess.
Well, we want to thank you again, Felicia, for your time today and for your important research. We would also like to thank LabRoots and our sponsor, Bruker Daltonics, for underwriting today's educational webcast. Before we go, I'd also like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.